My name is Walmyr. I work at Polaroid. I used to work at a company called Vamove, but I just joined Polaroid a few months ago. So we're trying to make a lot of like cool stuff there for cameras, like this, the i2. If you guys want to see the camera after the talk, please reach out. It's a pretty good device. So yeah, I'll be talking a bit about camera APIs in general, like how to use camera APIs for not only taking pictures and videos, but also like extending a bit with AR, ML, and some other cool stuff. Okay? I hope you like it. Yeah, the first fact, people use camera a lot. That's a fact. Who here buys a new phone only because of a new camera? Like, hands up. I'll raise both because I'm already planning to get the new Pixel just because of the camera. It's such a good reason. And yeah, like camera in general, like it's a good like. I think it's a powerful tool. Like everyone using like for sharing stuff, for capture moments, like for political reasons, like this protests. Like camera is everywhere. Like you cannot ignore. Like everyone has a camera. Everyone uses the camera. And another fact is like everyone is using cameras through the phone. That's a pretty like impactful thing. Like when you stop to think about, I think most of the apps we do today, they have a QR scanner. They have like a photo like status sharing, like Instagram, like WhatsApp, Facebook. And the biggest thing for me, like, it's such a powerful sensor, like the camera, photos, videos, microphone together. We do this, which sometimes we're not proud of. We go to the concert, it's like, we watch like 2 hours like this. But it's cool. We also do like social stuff with the family. We also play games, which is nice. So this is the new Space Invader. It uses like AR together with the camera. So like it's a game like Pokemon Go, but like in a really fun way. So you can actually play like while moving, which is pretty cool. And it's also like a convenient thing, like you can actually use like to get around, to go like explore the city. So camera can be used like for different aspects. I think like I never thought that I could use like a game, like have a game like using my camera, which is pretty fun. Like who played the Ingress before the Pokemon Go? Who was the player? Oh, the OGs. Oh yeah. Such a good game, right? It's like have this kind of like perspective on navigation, and also can actually point to this kind of places. I think it's cool. Like it's really nice to see the possibilities of cameras in general. I really like it. And also can be a good thing and a bad thing, I would say. Sometimes camera APIs can be used in a bad way. I'll mention 2 examples here, but like I think you know what I mean. Like this was the first one that got me a bit like annoyed by. Did you guys see this? The TikTok NPC thing? People doing like this kind of fake movements to get money. So like it's so weird like for me like to have a tool that enables people to do that. I don't judge the developers who made it, just to be clear. I feel a bit like misaligned with the business, like pushing that to production. I think it's a bit weird. Also another thing that I don't like is like these filters that kind of make people like look like too real, or maybe like kind of like hiding their imperfections, stuff like that. So my point here is just, it's such a powerful tool. We should be able to just like think a bit more, like be more mindful about how to use cameras, when to use it, why we're doing, like putting inside of our apps, just for the sake of doing it, or no, we really want to like empower people and just make applications better. So just a reflection for us to think about when considering doing like camera APIs or adding to our app, what do we want to build? That's my main point. Just like be a bit responsible on what we're trying to build. Okay? Cool. So yeah, I'm talking about cameras, I'm talking about API, I work at Polaroid. So the first question is like, okay, Vami, what about Polaroid? What kind of camera APIs do you use? And it's a bit tricky. And I'll tell you that. The issue is, if you check this device, this is the new camera that we have, the i2. It's a pretty cool camera. You have this kind of like all the settings, etc. But Polaroid cameras, like although they're like connected devices and super modern, Polaroid cameras are analog by design, so they're intentionally not digital. So it's funny when you go to Instagram and see people like, oh, can I save the camera on my phone? Can I save the picture of my phone? Can I just like share on Instagram? And the second comment is like, you need to buy a digital camera. There's like, this is not it. Polaroid is more like a niche company. They do like instant cameras, they do printers, they're not doing music boxes as well. But it's not digital, so the only thing we can do on the app side is stuff like this. For example, we have a feature on the app. We have a Polaroid photo app, and we have a feature that you can actually scan the pictures, and then the scanner detects the shape of a Polaroid and kind of like frames it, cuts the picture in a better way. So we are planning to actually improve these features and add more like explorations to that. So yeah, that's the elephant in the room, I would say. Like Polaroid is doing cameras, but not like inside the Android apps, more like as a companion app to the regular devices. Okay. So who here works with like camera APIs? Who has an app that has camera support here? Wow, plenty of things. Cool. So yeah, I'm just gonna give a bit of an overview on how to do like basic camera usage on Android. I don't plan to cover everything because we have like 30 minutes and it's a lot of content, so I'll try to be as brief as possible here. And if you have any questions, just please reach out. So if you're planning to do like basic camera support on your app, like photo, video, I really suggest you to use the regular intents. I think like the minimal API already covering most of the basic usage of cameras. So if you want to take a picture, it's as easy as request an intent for pictures. So this is pretty straightforward. Also, the whole system already takes care of the permission, etc. So it's not a problem. Same for videos. So if you need like to request a video recording, so this intent will request properly the intent needed for the video. So if just for that, you don't need to just do too much. I think that's basically like the basic structure of it. But yeah, sometimes you want to do more. We want to add a custom UI, you want to add a custom button, we want to do like a lot more with cameras. So how you can do it? So I'll show you a bit of how you can do it here, but just to give a bit of an example here, not an example, but it's like to cover what options we have. Today we have 3 options for camera, the camera X, the camera 2, and the camera. But it's kind of 3-ish because the camera API is deprecated. So you have the camera X, which is like the Jetpack version of the camera 2. It's like a layer on top of the camera 2. So you can just forget the camera API. It's actually Google actually deprecated, so don't need to worry about that. So we can actually use neither camera X if you feel like it, which is the demo I'm going to show, and also the camera 2 if you really need a detail, like more deep dive into the APIs. I think the camera X and camera 2 can cover pretty much everything you need. Yeah. So yeah, basically, library declarations, no big issues. Like here, you have a lot of libraries. You don't need to use all of them. For example, if you don't have video, I don't need to use video. If I only use like the capture, I can only use this tree. So you can have image capture, image analysis, etc. Also, the camera view is important because you need to make sure that you can actually preview your image. So make sure to add those, and then if you don't need like video, for example, you can just remove it. Just making sure that all of these most of them are obligatory, but some of them are optional. Okay. There's something important here, like you have these permissions. So for example, when you take a picture, it's just camera, but when you need to record a video, you need to have the audio as well because it uses the microphone. So we're going to ask for the microphone permission. So sometimes it's really common to see apps doing video but without audio because they didn't handle the whole audio capturing properly. Also, this is important. You need to make sure that for specific APIs, you need to request the right external storage because most of the time you need to save the image and you need to actually have media access to it. So this is important. In this case, if you use any, you're going to make sure that you're going to cover both front and back cameras. So you can actually use only the camera ones if you want. So that's mostly the case. There's more details in the documentation. I'm not explaining how to define permission because today there's so many different ways to define permissions. I'm not going to cover that. I think like if you already have an app in production, you're handling permissions properly. So it's the same thing, yeah. I think the general usage of camera through camera X is basically this. You need to provide a camera provider. This is just an overview, okay? There's a lot of stuff that you can actually evolve and just like push forward, but this is an overview. So you have a camera provider. It's also important to make sure that the camera, you can check both cameras, front cameras and back cameras. For example, especially now, we have this kind of foldable devices that you can use the back camera as a selfie camera. So this is important to check. So for example, for a Samsung Flip, the front camera can be the back one, the lens facing back. So just to keep in mind that like you need to provide support for these kind of new devices as well. So in case you need to switch, so the front facing camera is actually this one, and lens facing front is this one, and lens facing back is this one. So if it's a foldable, it's like this. So you have this kind of like checks on lens facing. And yeah, and then you need to actually have a selector. So if you have a button to switch them, you have this selector. So you pass through as a parameter how many lenses does it have, and that's basically it. Sometimes you have some exceptions saying that there's no camera available for a custom device, for example. And here you have this way to preview your image. So this builder, both the preview and the image capture, is pretty full of options. Like I cannot list all of them here. You can put filter, you can put flash, you can put a lot of stuff inside this builders. So make sure to check the documentation to see how many options do you have. If you go like builder dot, you have a list of many options you can do. This is just an example for image capture. So you have a preview. The preview basically is like, is this. So is this. So if I have the preview is like what is shown on the camera. The image capture basically defines what kind of things I want to define for my capture. So aspect ratio, capture mode, if I want to flash or not. It's kind of like configurations. Also, a lot of like rotation management. If you take a picture, for example, it's really common to see apps when you take a picture like this and the app is portrait locked, and you just do like this, the picture is ruined because you didn't consider people turning the camera, even if the UI already messed up like this. So this is important to check, the aspect ratio, the rotation, so a lot of aspects to check on that. Here is important, when you need to bind the camera provider through the life cycle, you make sure you need to unbind first, otherwise it gets messed up. So you need to make sure that you're always like unbinding everything first, and then you put the bind to life cycle on the try, so in case anything explodes, you can actually check what happened. So it's really common to see crashes because people overuse this whole binding and unbinding, so this is a good thing. Oops, sorry. Yeah, and here will be the capture part, how you take the picture actually. So for the capture, I need to actually create some sort of object here, and then I need to save this picture somewhere. So in order to take a picture, I need to have a place to save the picture. So I can actually put in memory, but like it's not a good practice, I guess. So here you can see I'm just saving a simple file. So I'm saying, hey, this file has a name, has a MIME type. You know when you go to Google Maps and you just like Google Photos, and you check the details from the picture, like the ISO, the location, etc. This is it. Like you can actually store a lot of information inside the picture. So the MIME type, the path. So you can actually, depending on the API, you can actually store a lot of details for the path as well, because you can actually have issues with content provider accessing your files or other apps trying to access your files. So this is important to check. There's a lot of libraries already doing that. I think Camera X did some sort of like abstraction of that, but this is important to double check. Yeah, this is also good. You need to actually expose some sort of URI to be able to access the image through the file. So here I have this kind of URI, so I pass all these values here from this content values. I pass it through, and I actually attach this to the output files. What it means is, when I take the picture, I just make sure that this picture goes to this place. That's what I mean overall. It's more complicated than that, but in simple terms, it's like this. Okay. Cool. And yeah, this is actually the image capture per se. So you have a callback when the capture goes right or go wrong. It's really common to see, for example, some apps when they don't. If you take a picture and you revoke the permission, the app explodes because people didn't take much care of the error side. So it's important to make sure that every step you're taking into consideration when it comes to dealing with the error case. So the happy path is like taking the pictures and saving it, but like maybe you don't have permission for the storage. Maybe you're saving like in the external storage, SD card. Maybe you have a OTB plugged or something like that. So it's really important to make sure that you're covering all the scenarios. So And here you can actually show the toast, say, hey, this picture was captured for this will be the place that it was saved. So yeah, that will be basically it for the image. This repo is really good. It's called Camera X Getting Started. It's a code lab. So most of these examples are inside this repo. It's really like open source. Google has a lot of code labs available for these kind of things. So this is a good one to check. I really like it because it teaches you in a way that say, hey, let's make the image first. Now let's make the video. Let's make image analysis. It's possible, for example, to check how much light does the image have. It's too bright, it's too dark. It's possible to Camera X support many other use cases, such like video capture, image analysis. Now they support like this kind of dual concurrent cameras. So you see those apps that you can actually record both video from the same time from the front camera and from the back camera. I think Be Real has that. Also Instagram is doing that. So this is really cool. Like they're actually adding new stuff. I think a few days ago, they announced that the Camera X 130 is stable. So if you check this link, it's on official Twitter. If you check this link on Twitter, they have like now effect library. They actually stabilize the video support, which is like on beta for a long time. So this is a good thing. You see on the image, you can check like you can actually add blur to the image. Like it's really common to see this on Google, like the Pixel camera when you take a picture in the portrait mode, kind of blurs the background. It's really cool to have these APIs to our own apps because it's really hard to make this kind of effect by hand. So I think it's cool to see this available. So yeah, please check it out. This libraries, I think it was this week they announced this. So I think it's a good one. Cool. It's funny because I was looking at the AR capabilities, and I think for AR is fine. The way to go is AR core. If you need to use AR in a less manual work way, why do I mean by that? Like if you talk to companies like TikTok, Facebook, Snapchat, I've met some of their developers and they do everything by hand. They don't use this. They do everything like C++, like really low level stuff. I used to work in a company in Brazil called ID Wall, and they use, do you folks know Onfido for like face recognition? It's an SDK for face detection, like document scanning. And they do all the stuff by hand, like C++, OCR, OpenCV. It's really like really low level. This is kind of an abstraction for like not wizard like us, like humane people like us. So this is like an easy way to adopt AR. And I was thinking, okay, this is already a big topic. And also, when you think about like ML capabilities, it's also like a really big topic because for Google, we have actually not only one but 3 ways to do machine learning on Android for Google. I'll mention those because we don't have much time to show all of them, but the first one is MLKit. MLKit is their way to just like say, hey, this is the easygoing way to just like face detection, QR code scanning, position detection, these kind of things. So I have a lot of like cool libraries inside of this package. It's like a jetpack for machine learning, I would say, a small pack. And then you have this kind of media intermediate way of doing it. It's called MediaPipe. MediaPipe is a more complex tool to handle machine learning, training, etc. So you have, for example, you have models such as detecting mood through a test. So if I have a string saying a phrase, I can actually say if this phrase is negative, positive, happy, sad. Also a lot of stuff for image as well, but it's more like a complete way. And the third way, which is the more popular one, is the TensorFlow Lite. This is I would say the big player, is the one that everyone knows. So you have 3 big ways to do machine learning on Android, and you start to figure out like, how can I do it? What is the best approach for me to do it? And I was thinking like, what if we combine like, what if we combine them in a way? Like I can actually combine AR with some of these tools, like this kind of like machine learning training models tools. I'm actually gonna demo now something. I hope it goes well. This is fine. I have a repo here, and I want to demo. I hope it shows well. Yes. Yeah, I have this demo called AR Core ML Kit, and what it does, I'll have it here. I hope you can see my screen. say hi. Oh, that's pretty cool. I'll take a picture. Oop. Yeah. So yeah, this is my phone, and I want to show this. There's a demo called AR ML Kit. What it does is basically like it's pretty cool because we have augmented reality with machine learning and also using trained models to label stuff. So I'll do here. You see this kind of small dots, like it's showing some dots here. You can actually see them like popping up. Where's that? Yeah, you see some dots. And then if I press scan, it kind of like starts labeling them like in a way that I can actually map using AR. So it's pretty cool to see like if I just map a lot of stuff, I can just like map different persons. So it kind of like labels it. Not only it's funny because it kind of tricks your mind. It's not only labeling them as a classification model, but also labeling them in the position in the AR. So if I do this, and if I go back, it's like the label is here. So it's like even like it's facing me. So this is just a demonstration on what kind of things you can do together. So what is happening here is like camera APIs together with the AR pinning, the positioning, together with the machine learning classification. You see here in the top, there's the Cloud ML. This is a remote machine learning model fetching from the Google Cloud Vision API. But if I turn it off and I just clear, I hope it works. But let's see. Yeah, I still have some sort of classification, you see? And what's happening here is that now I have a local TensorFlow, like an offline model. So this is interesting because I'm actually not connecting with the Google Cloud anymore, and I still have a bit slower but the same functionality. So I want to show you how we can do this. Of course, the code is a bit of all over the place, but I want to show you the basic structure on how we do it. Okay, I'll just turn off here, and that's it. So yeah, the first thing here, this project uses both AR Core, ML Kit, and also fetching TensorFlow model. Not only locally, but also fetching a model from a remote repository. So I'll just, can you see it from the back? Is it good? Okay. So here, first thing you need to do is to create this kind of like AR Core session lifecycle helper. What it does is basically like aggregates everything that's needed to make a AR session. When I talk about session, is the thing I did. It's just like I just turned off the camera. I did this kind of like visioning. I just checked everything, and like the session is like that. It's more like this time that I'm using, the showing you the AR environment. So yeah, and also here, this session is good because you can have a lot of exceptions here. So for example, when the AR Core is not installed, AR Core, it comes from the Google Play. So if you don't have the AR app installed through the Google Play services, you might have one of these exceptions. So maybe you didn't install it. Maybe you have like to update it, or maybe the device doesn't support AR as well. I don't have exactly the criteria. I think it's related to a mix of like GPU with Android version with storage. There's a lot of combinations. I need to double check on that. But this is more like a assistant on showing how you can actually use it. And why it's not working for some reason. So for no camera available, etc. So this is the first thing. And here, the way the AR Core goes is a bit different from the Camera X. They have their own way of dealing with the camera, mostly because the focus on AR is not like camera image quality. They need to check three things on AR. It's like the space, if this is a flat environment, if this is a wall, this kind of like environmental context. And second, like the deepness, for example, how far is here compared to the shoe that the guy is using. So it's kind of like deepness. And also the lighting. For example, it's really common to see Google doing this kind of models, like when you under the light, the model behaves differently because you're actually shining the model with a different lighting. So that's why you need to make sure that if you use AR Core, it deals differently in a different way. So that's why. So here you have this kind of like way of focusing stuff. So I'm not going into much details on the camera configuration here. It's more like a setup. And it's important to mention that it's really similar to the way we do regular camera. So we need to add this to the current life cycle. So it already has a way to add this as an observer. So like using the proper life cycle from Jetpack. So this is fine. Yeah. So here's already like just like gluing everything together. So yeah, this is cool. The thing I want to show you is like this. When you have this main activity, we have this thing called, second. Yeah, this one. We have this thing called app renderer. So what we do here is basically like set everything on this handler, and then we add the life cycle to the handler. What the handler does is basically like attaching a lot of the AR rendering inside of the activity. So you see here, you have different ways to map the objects. They have something called object detector that I want to explain later. But basically what's happening here, when I show you let me show you. When I have this, and I have the, oops, sorry. Ooh, yeah. When I have these labels here, I just create a list of the labels here, like the anchors. So these kind of red labels are the anchors here. And the only thing I do, it looks super complex, but it's pretty simple. I use these object detectors, the MLKit object detector and the Google Cloud, to fill this list. So this list is basically like an array. I just put items there, but the thing that positions these items is based on like the positioning, the label itself, and the confidence, I would say. So if I have this, let me just show you. So you see for the anchor here, I have this kind of like just the anchor, which is an AR core model. So the anchor is basically each label is an anchor. So and the label. So the label is like the object itself. So let's go up a bit. Yeah. So what it does here is basically this, and I have this kind of analyzer. So so when I press the button on top, it kind of switches between the GCP and the MLKit analyzer. But I want to show you what we do with this. One second. Oh, sorry, this one. Yeah. So here, the analyzer is basically like this. It's gonna get for the MLKit, I'm using a local TensorFlow model, which is based here. So if I go to the assets folder, I have a file here, which is a TF-Lite file. And you might ask, how can I get this file? Is it paid? It's for free? It is free. It's open source. So if you go to a site called TensorFlow Hub, is the older version. We have something called Kaggle now. Kaggle is like the GitHub for machine learning models. So if you need to have any kind of machine learning model inside of app, you can use Kaggle. There's a lot of free open source models for example, fruit classification, animal classification. And it's funny because when you think about how much does it, this must be like 5 gigas, 10 gigabytes. Like, is it too big? How big it is? And it's not. This one's actually like, I think it's 100 something megabytes. So if I go here, let me just go to the project again. So if I go here and I check the file, 1 second. Yeah, so you see, it's not so big. It's like 170 megabytes. So what the magic that TensorFlow does is like basically like converting a lot of knowledge that a machine learning model does into like a really small package. So anything, for example, there's an app called Be My Eyes. You can actually take pictures to help like blind people to navigate, and they actually have a session with you, so you can actually say, hey, what am I looking at? And you say, hey, you're looking at something. They just started doing like machine learning, like ChatGPT-like way of describing things. So this can be done locally, like I did now. I just show you like how to classify things like locally. If you have a proper trained model, it's really easy to do it. So just like convert to a TensorFlow Lite model and just put inside. And the way the project is reading, like here, if I do a MLKit object detector, I can just pass the model here, and then it's gonna create for me the whole thing. So if I search for the model, 1 second. Yeah, it's here. So if I search for the model, I can actually have it here. like I can actually create a custom detector options, and I just pass the model as a reference. So this is already a super powerful thing. So I don't need to do much on my code to make something like super smart happening. And here I can actually say, hey, this model is going to have a single image mode. So what it means is like I need to pass at least a full bitmap for the analyzer to match. And then once it's matched, it's already like taking consideration the anchor thing that AR core needs to map like officially. So for example, if I don't want to do, if I only want to do the Google Lens thing, like take a picture and analyze, this will be enough. I don't need to use AR core at all. So for that, this kind of classification, MLKit is already enough, because the MLKit is based mostly on the image classification. So if you go to the website, MLKit, oops, sorry. So if you go to MLKit and you see like what kind of APIs they have, most of them are like image classification. So barcode scanning, face detection, face mesh, all of these things are already like models, similar models to the ones that I actually show. So this is a similar behavior. So here, what it does is basically like analyzing the image that I put, based and crossing over the image that I put with the model that I have. So I don't know the internals like a black box per se, but like everything's already available. Like MLKit is already available. It's a free tool. But the thing is here, like you need to make sure that this detector is gonna analyze this. And also, did you see that when I showed the labels, it kind of like shows in a rotating way? Kind of like helps you to put this how much the image is rotating based on the camera vision. So kind of like do some sort of parallax. A bit of tricky situation, but like you see, it's not so complex to do it. Only this is already creating the classification I need to check objects in real life based on the bitmap object. So if I have a chair in my bitmap, it's gonna throw this in the object, it's gonna do the math, and just come back say, hey, this is a math, this is a chair. And also, the thing it does, it has some sort of, let me just get here, because each anchor has a way of, let me just get it here, 1 second, helpers, sample 100, label header. 1 second. Yeah, the anchor has some sort of accuracy, so how precise is this? So you can actually make a model, train it, and just like say the accuracy is a bit low, so let's put more images on the model to train it better, so I can actually have more precise ways. So for example, a friend of mine was doing a way to classify like money bills. So say if I'm a blind person, I can actually point and say, hey, this is $5, this is $10. I can actually create a model to say in a precise way that this is actually this current. So it's really like powerful thing. So yeah, and here, what it does is basically like convert this and get the objects here mapped, and then it gets this kind of like detect object result, which is what I need basically. So what I mentioned is like you have the object, you have the float, the confidence, the label, and the coordinate is basically like where the positioning of the object. So it's basically it. For the Google Cloud one, it's a bit of a tricky situation, because what it does, it's a bit tricky. I'll just try to go a bit over. It gets your credentials on the Google Cloud. What? And the way it does, like you get this kind of image in rotation, but the only difference is that you need to make sure that you're hitting this kind of remote model. So the only difference compared to the TensorFlow local one is that this API is fetching a model that's up to date. So if I want to use something that's like more precise, like maybe GitHub model or something more like more concrete, I can actually use this one. But the way it goes, like actually runs the analyzed image in the same way. So the only difference is this convert UI, YUV model, but other than that, this is really similar. And the only thing you need to do here, they have this kind of like, I think it's, yeah, they have this kind of like image annotator client. It's like an API from the Google Cloud library. And this library helps you to do the same classification that you did on the local TensorFlow. So that's basically the difference on those. But you see, like both of them returns this detect object result, and then this result is going to be listed here on this kind of anchors. and I actually show them across the whole thing. So that's why when I do this, when I use the cloud one, and I just like, I do the scanning, I just doing a lot of labels, but I'm not actually like, I'm just like adding them to a list. So I can actually build up and put a lot of stuff in the same thing without like over performing, like burning in all of the battery, because it's like simple, like action, reaction, action, reaction. So it's really like, it's straightforward. Oh, I have 5 minutes. And just go back to the slides, 1 second. So yeah, again, just to show you a bit on the Google Cloud side, this is the Cloud Vision API. So if you create a project in the Google Cloud panel, and then you have this kind of like Cloud Vision API, you need to enable it. And in order to be able to get returns, at least for an experiment, you need to enable the billing. We have like 300, I think we have 300 euros of free budget. But like for experimentation, for trying it out, it's really good. So Cloud Vision, and this is for the remote one. And for the local one, this TensorFlow Lite / Kaggle TF Lite model. So just put it here inside your assets file, and that's it. Of course, it's not so trivial. You need to know a bit more on how you navigate. You need to just do some trial and error. But like, it's not like weird magic. It's like, it's really like ground floor APIs, like well documented and stuff. So if you want to check it out, this repo, it's not mine, it's a repo from Google. So they have a repo called github.com/Google samples /ARCore-ML-sample. So it's funny because I can actually change the code to match a different custom model if I want. So it's really common to see like fruit classification, animals classification. You know, a lot of those apps that classify plants, how to check how the plant have some sort of disease. This is also a custom model inside the app. So I think it's really possible to just go wild, like, and do plenty of stuff. So to summarize, for me, is like, in terms of like camera APIs in general, like camera X is the way to go when it comes to just like photo, video. Just go with camera X is the right thing to do. If you combine my MLKit, ARCore, and TensorFlow, also the other ones, MediaPipe, etc., these are really good tools to start. I think this is just like a brief overview. I think you can do a lot more. I'm actually planning to improve this talk and put a custom repo to make it like more exploratory. The Cloud Vision API is really powerful. Like Google uses it for a lot of stuff. Google also uses the MediaPipe for Google Photos, for a lot of like internal products. So it's really something they made inside and just made available. So you really should be taking care of it. There's plenty of like content available, like on Code Labs, etc. So let me just show you something. 1 second. The last one is this. So if you go to the Google Code Labs and you just filter for AI, machine learning, and AR, and also put the Android filter here, you see there's a lot of repos. So please, 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 just check it out. It's really good thing to try. And last but not least, I'll try to do something here. Not sure it's gonna work. I'll try to take a picture of you all. Let's see here if I have. Yes. Just say smile. 1 second. I need to make this happen. I'm sad that's not gonna fit everyone, but I'll try to make it. Just say cheese. Yay! And that's it. Thank you so much.